it does, but after a few passes with this thing, it's now nice and smooth. It's time to face the two flat sides now. I'm misappropriating the same boring head as a fly cutter now. I first started doing this using a big face mill, and I was getting some really bad chatter and an awful finish. I'm still getting some chatter even with this setup, but it's way better in comparison. The problem with this part is that it's pretty thin relative to its overall size, and that means it has a tendency to vibrate when you cut it, which creates chatter, and I don't really have a way of clamping it that completely eliminates that from happening. So I still didn't get a perfect surface finish this way, but at least I got one that I can live with. There's only one last feature that's missing, which is this channel that the belt tension column will slide up and down in. It's basically a linear guideway that eliminates any side-to-side movement of that part. Just doing the last finishing touches now. Yes, I know, my work table is shaking way too much. Okay, that was a lot of work, but it's finally done. It's nice and shiny. I didn't mess up, and we can move on to the next part. Next part is this long column which slides up and down in that slot you just saw, and it's the main part for the belt tracking and belt tension mechanism. As with most of these parts, I'm starting with some raw hot rolled steel again. The stuff is usually not really dimensionally accurate or even straight, but since I'm facing all the sides anyway, it doesn't really matter because most of the stock material I bought oversized, so I have enough material to work with when I take it down to final dimensions. As I was doing these cutouts, I realized I must have smoked this cheap carbide end mill when I was building the last part, so that's why it's screeching and leaving a bad finish, but it's nothing some Scotch-Brite won't fix in this case. Now here's that angled cutter again. This is actually not really meant for cutting chamfers. It's a 45-degree dovetail cutter, so I'm actually using it upside down here, which means I also have to run the mill in reverse, but it's what I had and it came in really handy for these parts. I'm also making two little axles here from some stainless that will connect to gas springs. I actually slightly changed my design later to only use one gas spring, so these won't be needed, but for now we'll just go with these. Now this thing is finished as well, came out pretty nice, and next up is the hand lever that operates the tension mechanism. That's actually two parts, but we're going to treat it as one. I'm just starting with some basic flat bar again, and you might already notice these facing and drilling operations, they repeat over and over for pretty much every part, and it's always the same, so I'm not gonna go over that stuff in detail each time. Now this here is exactly the sort of thing I'm most likely going to be using the grinder for. Doing these roundovers on the mill is pretty overkill, it takes pretty long and it's not really necessary. I'm just doing it because it's the only way I have if I want a nice looking result. Here's the second piece, which is just an extension for the lever. I made this in two pieces because I wanted the handle to be adjustable, since I wasn't sure which position would be comfortable to use. A wise man once said, if you can't make it perfect, at least make it adjustable. Next we're gonna make the parts for this steel sandwich here, the top and bottom part for the attachment sleeve. I didn't have the right size flat bar, so I just cut down a wider piece. For the sides I can mill these down together, because it saves me some work and it makes sure they are identical. These parts look deceivingly simple, but they actually need to be pretty accurate if I want to get a good sliding fit for the attachment arms, so I had to pay some extra attention here to keep things square and within dimensions. So this time I actually am using a spot drill because these holes are so deep and they need to be exactly in the right place. I'm gonna let you in on a little secret here. Yep, I actually broke a tab in one of these holes, but luckily I broke off so deep inside that I was still able to have enough thread left to install this part. So I guess I got lucky and it just lives in there now. Next up is the side cover for the sleeve, and this one's not very interesting, so let's go over that quickly. I might have skipped over some stuff there, but it's just a rectangle with some holes in it. Next up are these little hinges, and once those are done, you're gonna see some of these parts actually come together. Alright, now that these two are done, we have enough finished parts to start the first round of assembly. Just in case you're wondering why I didn't countersink the screws on this side, as you can see there's not really enough material towards the edge to do that in a clean way, and I didn't want to make everything even bigger just to accommodate that. Not gonna lie, putting this together and having everything fit perfectly was pretty damn satisfying, and even though it's not really surprising with these machine parts, seeing that everything comes out perfectly square is very nice, even though this amount of precision is completely unnecessary for the kind of machine I'm making here. Okay, now let's go over my overcomplicated belt tension solution. So the column goes in the slot and then it gets secured by two bolts with lock nuts, which allow me to adjust the place so it can slide up and down while allowing very little movement in any other direction. I like using plastic washers because they reduce the friction between metal parts and they are replaceable. I made these washers on the lathe and they're made of Teflon, which further helps to keep stuff sliding smoothly. And as for the column itself, that's going to be lubricated by some whey oil on the final assembly. Looks like that works, so now I can attach the gas springs. These are two 90 Newton gas springs, and like I said earlier, I eventually changed this setup a little bit just to use one spring on the drive side that has twice the amount of pressure, which is a bit more elegant and it gave me a slightly better overall tension, but this method here also worked okay. Okay, here's one of my favorite features about this. This entire mechanism actually locks into place automatically in the retracted position using this spring plunger here, and that allows you to easily change the belt without having to hold anything.